Hello, is everything? I joined the wrong meeting. Sorry, I'm late. I actually goofed up and I clicked on the wrong link and joined the wrong meeting. So is everything okay? Do you hear me?
Yep.
Okay, great. Yeah, I have this long list of meetings and I just somehow managed to click on the wrong one and I was in a meeting by myself. Had to get out and restart. Okay. Um, there. Okay. Okay, so there's first of all, there's one last reading assignment, a couple more sections about classes. We're going to spend this week talking more about designing classes in Java. So this is the last reading assignment. You have a homework assignment, okay? Yeah, and it's due today. So if you don't have it done, keep working on it. I put it down. I put the due date as today. Okay, this is the last week of the semester, but if you can turn it in later this week or early next week, that's fine. You'll get full credit. But so first, let me ask: anybody have any question about this homework assignment? So anybody who has got any question that they have about this assignment so far, anything that's come up? Let's see. Somebody wrote in a text. I don't know what you mean by use different numbers.
Like, do you want us to use different numbers than what you've provided us in the
Yes, yes,
example input?
yes. It says that in here. You should test your program with lots of different inputs. That's why here. Let me the program comes with the test of the generator for generating lots of inputs. And the page says that you should test your program on, because if you just run one set of numbers through it, that gives you some confidence, but you get a lot more confidence if you try other numbers. So for example, if you open this folder and you run this, I can generate, say, 100 numbers. Here's what the graph should look like. And here's the 100 numbers. Okay, so I can take those 100 numbers and I can cut that and put it in this folder and run the program with different numbers. Then I can go back here and run this program again and ask for 1,000 numbers. Okay, and those 1,000 numbers are right here now. Yeah. So you see, it's real easy to get new sets of numbers. These programs generate the new numbers for you. Every time you run, you double click on this and you can say how many numbers you want. Like if you want a small number of numbers, you can get there's 5 numbers. Okay. And the 5 numbers are in this file here. There's 5 randomly generated numbers. Okay. So, and also when you have your program written, you can open it in Dr. Java. So, and you can test your program with just numbers you type in. And you should start off by testing your program with, I mean, this is just okay, this doesn't do anything. Okay, but you can, compile this and run it, and you should run it in Dr. Java and type in some numbers. And just make sure that your program does the right thing. So you can just type in 3 or 4 numbers, 3 or 4 grades. So you should always be testing you should come up with ways of testing your program to make sure it's doing the right thing. Okay. So certainly at the in Dr. Java, you can type as many numbers as you want, and typing in 4 or 5 numbers is a good way for you to see that you're getting reasonable answers, that you get reasonable graphs. If you type in 5 numbers, those 5 numbers should show up in your graph. Okay. Okay. See here, this one had only 5 numbers and they turned it into 4 different grades. So there was one grade that had 2 numbers. Yeah. and you could type those kinds of things in yourself and make sure that a grade gets put into the right bin. You know, type in a grade that's in the A minus bin and make sure it gets put in the A minus bin. Type in a number that's in the C plus bin and make sure it ends up in the C plus bin. You know, type 3 numbers into the A bin and make sure you get 3. You get the right length of the chart. Okay. Like for example, if you type in 3 numbers that are all A's, you should get 1 bar that goes all the way over to 100%. Okay. If you type in 2 numbers, one that's an A and one that's a B, you should get 2 bars. One that goes up, one in B that goes up to 50%, and the other in B in A that goes up to 50%. So you can really make sure that your program is doing the right thing. You can type in just it's actually very useful to type in 2 or 3 numbers. For example, if you type in 3 numbers that are 3 different grades, you should get 3 bars of 33% each. If you type in 3 numbers that are 2 A's and a B, you should get an A that's 66% and a B that's 33%. Okay. So do all those kind of little tests, and you'll be pretty confident that your program's doing the right thing. And just that all you're doing there is typing in 2 or 3 numbers. In this case, do it right in Dr. Java. Just type in, because the point of the program is that the program, it uses a scanner. Okay. By using a scanner with system.in, if you run it in Dr. Java, you can type in numbers directly. And if you run it using this test script runs your program using that data file. See, that's what makes it use the data file. So when you double click on this thing, it won't run now because there's nothing. It'll just give me an error message because I don't have the class file for it to run. There is no class file in here right now, but so it just gives me an error message. So you can run it using the test file. You can generate as many test files as you want using the demo program. And you can just run it directly in Dr. Java. And actually, that's probably where you should do most of your testing, is in Dr. Java. Like I said before, give it 3 grades, make sure you get 3 bars, give it 4 grades in 3 different classifications and see that you get the right kind of bars, like 1/4 and 1 grade that's 25% and another grade that's say 75%. Okay. So, and I'll test your program a little bit like that. I'll run it with a couple different data files. I can run your program with different data files. I can run a longer test script than this. See, I could test a program with multiple data files by just doing this and doing data 3, data 2, and I could have 3 data files. Okay, and then I could produce 3 output files. See, I just wrote a little program that would test this thing with 3 different data files. So I could have 3 different data files in there and run a program with 3 different data files. I could run it with 10 data files. The beauty of this is, if you need to run a program in a production environment, you could run a program thousands of times this way. You just can, and that's what people do in the real world. They use programs to run other programs. Essentially, this is a little program. Yeah, I can execute it. And this is a little program that runs a bigger program. In this case, it'll run the Java program when it's completed. Okay. And that's how the world works. Little programs run bigger programs. And then they can process large amounts of data that way. So part of what you're learning is ways to test things. How do you know something is the right answer? And that's different than a math class. In a math class, when you want to know if something's the right answer, you go look it up, or you ask a teacher, because it's kind of hard to tell sometimes if you have the right answer. Like if you can just do the work over again. But in programming, very much a part of programming is proving that you have the right answer by testing. Okay, you have a program, that's the answer, and then you run the program with lots of different inputs and you check the outputs. That's testing whether it's the right answer or not. So it's a real good point is that you should be, yeah, you should definitely think in terms of how I can run the program with lots of different ways. There's no one output that's really, this was just one sample output that you should get from that data that was originally here. You should get this output, but that's, testing it once is good. Test it, and also when you're writing it, testing it on everything is not always not the best way. If you're trying to find bugs, this is not the best way to find a bug. Like you may have a bug in how it generates C++ or something. So small, like this had 150 data points. Small batches of data with 3 or 4 numbers in it can be better for finding errors in your program. So this will tell you this will give you confidence when you're correct, but it won't help you find mistakes. What'll help you find mistakes is running the program in Dr. Java with just 4 or 5 input numbers. Okay, so type in 4 numbers and then type in -1 and make sure you get the right output. Then run the program again, type in 3 numbers, type in a -1, make sure you have the right output. Okay. What about other questions of the homework?
I have a question. I have a Mac, and how do you run the run test script CMD? How do you change that to be executable on a Mac?
Well, there's a couple ways you could do it. You could just, let's see, let me download this again. So I'm back to I made changes into that. Um, there, one way is if you can open it. Have you ever opened a command prompt in your Mac?
Like a terminal shell?
Yeah. Mm-hmm.
Yeah.
Yeah. So one way, let me is if you open a terminal shell in this folder. So and on a Windows machine, I would open the terminal shell this way. I just type CMD here, but there I get a shell in that folder. So you open a shell in that folder, and then you can open that file in an editor and just copy and paste that line. Just copy it, copy, and paste it into the shell. That'll do it.
All right,
So
perfect. Thank you.
yeah, that you can just run that command line in the shell. That command line itself is the same for both Windows and Macs. Okay, they share this little bit of the command language. Okay, so that's one way. The other way would be, this may not work as easily. You can just drop the CMD from this. Okay, you drop, and then it becomes a shell script. Well, no, it doesn't. But then you have to delete the echo off, and you have to delete the pause, and now it's a shell script. Yeah, now it's a bash shell. Okay, and you could possibly change the script extension. I can't remember if on a Mac if this works. You could change it to sh. Yeah, and then you. But I don't think you can double click on it. I can't remember if you can double click on shell files in a Mac. Okay, but if you delete the pause, you delete the first and third lines of it, and then change the extension to sh, it becomes a bash script. But probably the easiest thing to do is just copy and paste that one line just copy and paste that line directly into the terminal. But you have to have the terminal open in that folder. Okay, so that it has access to the data file and it has access to your compiled program. Okay, so the key is to be in that folder where your homework3.class file is. So compile your homework3 program first, and then it has to be in the folder where that is. Now the demo programs, you should be able to run the demo programs too. To run the demo programs, it'd be the same idea. You would just open that folder and essentially these 2 lines here, paste them into a shell script, into the shell, you know, paste that line and that line into the shell script. Okay. Okay, but you'll have to put the number of data points you want here. You have to replace this thing with, like, if you want 1,000 data points, you would copy and paste this into the shell with the number 1000 there. Okay, and then you'd copy and paste this into the shell and you get the graph output. Okay, so these you can run these demo program, but you'd have to run it in the shell yourself.
All right, thank you.
Okay, all right, and that's good practice. I mean, using the shell is that's another thing that this class ought to be about, but we don't. The textbooks don't want to be when the textbooks don't want to write. If you're on a Mac, do this. If you're on a Linux machine, do this. If you're on a Windows machine, do that. So they avoid the command prompt, but the command prompt's incredibly important. It's incredibly useful, and I think the textbooks should just say, if you're on a Mac, do this. If you're in Windows, do this. If you're on Linux, do that. But they hate that. The people who write the textbooks don't want to do it, so they avoid mentioning the shell altogether. But the shell is incredibly important. So, like on your Mac, if you're getting comfortable, if you're using the shell, that's great. And if you're on Windows, it's kind of worth it to start learning how to use the shell, how to start using the command prompt. It's tremendously important and tremendously useful to be able to work with these things. You know, so I need them just to even give you little demo programs. These demo programs would be really hard to use without being able to do this kind of thing, having a little shell script that you can just click on and get a million data points. Okay, so it's real useful to be able to run these things. See, there was a million data points. It only took a couple seconds. Okay, now those million data points are in this file here. Okay, so the programs that run programs are useful. So shell scripts that run Java programs are real useful. But they don't. But there's no universal language for these shell scripts. Linux has its own language for writing these shell scripts. This is written in Windows shell script, and Macs have their own shell script. But luckily, that one line there is the same for both. Okay, so that's why you could just copy and paste that line into your command prompt on a Mac. Okay. Okay. What about other problems? Other questions about the homework assignment? One real goal of this assignment is to get you kind of used to this idea that you can run a program with data that's outside the program. That's actually a big goal of this assignment, is to get, because again, most of the textbooks, because this is Windows based or Mac based, notice that the way you run your program now, to run the program with a million data points, I kind of have to do something on a Windows machine that's a little bit different than what I would do on a Mac or Linux. So textbooks tend to avoid these issues, but they're unbelievably important. They're really what you should be learning. So this idea of writing a program that gets its data from outside, like instead of just getting the data from right inside Dr. Java, that's a good way to test your program, but the real goal should be that the program can get data from outside of itself. So it doesn't have to be all in Dr. Java or in whatever IDE you're using. Programs don't run in IDEs. Nobody in the real world ever runs a Java program or a C program or a Python program from inside of the IDE. Programs run in the real world and they get their data from the real world. They get their data from files. It's almost always the case that they get their data from files like this. And then they put their answers in files. Programs out in the real world get data from files and put their answers in other files. Okay. So this assignment partly is to get you, it takes some getting used to. Get used to this idea that a program is going to get data from a file and put data in a file. And that's what this command here does. Runs a program, it gets data from that file. That's what that less than symbol says. This program gets data from that file. And this is pointing to where the data goes. So the arrows, you think of these as arrows. This says send that data to the program. And this says from the program, send the output to that file. Okay, so it's kind of it's written in a way that tries to help you understand it. You can put these things in either order. This is the same command here. It still says run this program, with its output sent to that file and run this program getting its input from that file. Okay. Luckily, this part here is the same in Java. It's the same on Windows and Mac. So you write this exactly the same way on Windows as you write on a Mac. Though other things aren't written the same way. This line here is written the same way. Okay. So running a program, getting data from a file, and putting data in a file, that's important. And what's really important is that this happens for free. Your program just uses standard in and standard out. Your program doesn't need to even know about this. Okay, and I can, yeah. If I just write something real simple here, int x equals in dot next int, okay, system dot out dot print line x. Okay, that program reads in one number and outputs another number. And to get this to compile, for now, I'll just delete. Oh. Okay. Okay. So this compiles. I run it, type in number, get out number. Okay. If I go back over here, I can run that program. Oops. Okay. The program now is going to read. So I'll open test data. And put one number in it. Okay. There's a number in my test data file. So it's just got, the test data has just one number in it. Okay. Run the program. Okay. I just ran that program. See, that number appeared in that output file. The number just got transferred from that input file to that output file, which is what happened over here. It's the same thing as if I ran this thing over here and typed in 123 and get out 123. If I want to run the program with a different number over here, I can put in a different number in the input file. Okay. There's the script that runs it. There's the input data. Okay. There's the output. Run the program the hard way. Go over here. See, something updated this file. See, now it's got 456 in it. This Java program ran when I double clicked on this thing. The Java program ran, it read a number out of that file and wrote the number that it read into that file. Okay. And right now I have the two files, the input and the output file open in. It's like a slow, cumbersome way of running Dr. Java, but this works good when you have lots and lots of data. Okay. So in my editor, I have the test script, the input data, the output data, and I can change the input data to anything I want. Okay. If I put two numbers in here, it won't help. It's only going to read one of them. Okay. The program only reads one of them. So if I put two numbers in there and run the program, See, it only read one of the numbers. So there could be two numbers in this file, but my program didn't have a loop or anything. It only read one number. So it read the 23 and it put the 23 in this file. Notice, real important. And people have been asking me, writing emails about this. Notice that this program has nothing to do with files. Notice that this program knows absolutely nothing about files. And I get people who are Googling how to read a file and ask me questions, and that's really getting on the wrong track. Java you don't need file. System.in, the scanner is tied to system.in. In Dr. Java, system.in is this prompt here. But out here, I'm changing what system.in is with this. That's changing what system.in is. Okay. On the other hand, system.out, I'm changing what that is with this. That's what these symbols do. This greater than symbol changes what system.out is. It changes it to be that file. This symbol changes what system.in is. It changes it to be that file. Instead of being the keyboard, system.in now, because of this, system.in is the keyboard. And system.out, I'm sorry, because of this, system.in is that file, and system.out is that file. Okay? So it's real easy for a Java program to read from files. You just have the operating system do these changes for you. When you run the program, when you run the Java program, you say, oh, and here's where the data comes from. But the program's still reading from system.in, and it just doesn't know the system.in got changed from being the keyboard to being a file. Okay. So that's part of what this assignment is about, is this really powerful idea that we can write programs that don't know anything about files, but then the programs can use files. But we need the operating system to help us.
I have a quick question.
Sure.
Are we changing any of the content inside that file, your run test script, if you have a Mac?
No, just copy that one line out of it.
Okay, I'm doing it, and I'm getting cannot find or load main class in homework 3.
Did you compile the program first?
Oh, okay.
Yeah, so you have to have the class file. See, you have to have, now watch. See, watch. I'm going to delete that class file. Now I'm going to run my test script. I'm going to run the test script. See, there's that error you got.
Yeah.
Yeah, see, because I deleted the class file. The class file is not there. Now I go back here and compile the program in Dr. Java. Go back here and type that command again, and it works. See, the class file has to, see, you're running the class file. You're not running, this is one reason why I think this example is really good. In Dr. Java, you get the feeling that you're running the Java program. See, here's my Java program, right? So I click the run button. What am I running? Oh, I'm running my Java program. No, you're not. You're not running the Java program. You're running the class. See, and if you don't compile it, the class isn't there. So even in Dr. Java, if I delete that class and I go over here and say, no, look, the run button disappeared on me. See the run button grayed out? Dr. Java saw the class is gone, and it won't even let me click on the run button. I've got to click on the compile button. Oh, there's that class file. Now I can click on the run button. So you're running the class file. Okay, and this is part of what we're trying to, this is part of getting used to the Java, and that's one reason why IDEs like Dr. Java can actually be as harmful as they are good. They can easily build misconceptions in people's mind about what they're doing, like that you're running the Java program. For example, if you write a Python program, you run the Python program. Python is a different kind of language than Java. If you open a Python program in an IDE and you click on, there's no compile button, there's only a run button, and you're actually running the Python program. But Java is a language like C and C++. You don't run the Java program, you run the class file. Okay, so before you can type that command, you have to have the class file compiled. And use Dr. Java to compile it. Yeah, use Dr. Java to compile, though you actually can compile on the command line too. So here I'm going to delete that class file. And on the command line to compile, you just type Java C for compiler, homework3.java. See, that class file reappeared. That's all Dr. Java is just typing that line for you. When you click that run button in Dr. Java, it's only doing that. It's calling the Java compiler, which you can do here at this thing. It's just telling the Java compiler to compile your program. So again, I can delete the class file. And over here, I can just say recompile it. Okay. And then I can say run it, Java homework 3. And now I'm running it here. It's waiting for me to type the input. See? When I run it this way, it just says, well, I need input. So it's asking me for to type an input. Okay. If I run it this way, I can say, get your input from test script, test data. See, it told me the outputs. See, I didn't have to type anything. I said, get the data from here. But since I didn't do the other redirection, it read the 23, but printed it out on the screen. Now, if I do this, this is telling the operating system, run this program. System.in is the keyboard, because I didn't tell it otherwise, but system.out is that file. So now when I run it, it's waiting for me to type a number. But where'd that number go? That number went over here in that file there. So I redirected the output, but not the input. Okay, so over here, again, that was, I run my Java program and say, but I want the output to be saved in this file, but I didn't say where the input will come from. So the input came from the keyboard. Okay. Notice that this is, I can do a lot more here than I can do in Dr. Java. I could have it read a file. Well, here I'm having it read data from the keyboard, but put the data in a file. I could do it the other way around. I could have it read data from a file and output, and then give me the output on the screen. So there it read the data in that file and put the output on the screen. And I can do both here, and then I could put the output in. Now it's going to read what's in that file and send it to that other file. So now I've got another file over here that's got that number in it. Okay. So the command prompt actually lets you do all kinds of nice things. You can compile your program, you can run your program from the command prompt, and you can manipulate large amounts of data. That it makes it real convenient to work with large amounts of data and test your program in different ways. Okay. Okay. So again, Java programs don't have to know about files. They get them automatically. System.in could be a file, and system.out could be a file if you run the program this way using the command prompt. Okay, if you run the program from the command prompt. Okay. Now, I told you the textbooks don't like to talk about this stuff. If you go to the textbook that we're using, one of the textbooks we're using for this class, they have he's got an appendix on tools. I think it's in here. The command line interface and command line testing. See, the things I'm talking about, see right there. He mentions it a little bit right there. He doesn't say much. He says about the same thing that I've just, but he actually, this is one of the few books that actually does mention it in an appendix. Yeah, so it's buried over here at the very end. What is the end of the book in a little appendix on tools, which is actually kind of a nicely written a chapter. This is kind of a nice chapter, this tools appendix. So if you haven't looked at it, you might want to look at what's in there. But this is where he actually says things like command line interface and command line testing. So that's what we're talking about over here, using the command line for testing. Okay, and that's exactly, see that there's what we're talking about. Okay, dot in files and dot out files are kind of a bad idea because it'd be better if it was test dot text. In dot text and out dot text would be better names for those. In dot text, so you could read the file easily, and out dot text, so you could read the file easily. If you have a file called test.in and you double click on it, nothing will happen because .in doesn't mean anything to Windows and .out doesn't mean anything to Windows. So these would have been better called in.text and out.text. Okay. All right. So there's a little bit about this in the book in the Appendix A on tools. Okay. Okay. What about other questions to the homework? It's real good to talk about this stuff. It's that's the homework assignment is supposed. Oh, so many people wrote. Let's see. Oh, would you recommend? No, don't store the data in array. That's a real bad idea because if I tell you to run the program with like 10 billion items, you're gonna have a hard time dealing with an array that big. You don't need to store the data in array because what you need to do is as soon as somebody gives you a number, you decide, is it an A, B, C, D, or an E? And then you just count it and throw it away. Okay. You store the grades in an array if you want. You could store the grades in an array, but not the data in an array. So it depends on what you meant by data. Okay. You could create an array kind of like this that says how many A pluses there are, how many A's there are, how many A minuses there are. But then the array has size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has array size 13. Okay, so there's 13 data things there to keep track of. You could use an array for that, but don't use an array for this because that array could get huge. And you don't need, see, what you need to do is read that number and add it into the slot it goes in here. Like 87 is a B plus. So you'd increment that, whatever number's in there, you'd say, oh, in the 0, 1, 2, 3 slot, I increment that number because 87 is a B plus. Then read 72. 72 would be a C. So you'd increment the number that's counting C's. Then you could throw the 72 away. Read the 85. Then 85 would be B plus. So you increment the B plus counter, then throw the 85 away. So you don't need to save these. Okay, that's not a good strategy in this case because you never need to go back to these numbers. Once you've read that number and classified it, you never need to go back to it. So you don't need to save these. So that's not, so you don't even need an array for this. You could just have 13 variables, or you could have an array of size 13. You could either have a variable called A plus, A minus, B plus, B minus. You could have 13 variables with names like A plus, A, or you could have an array of size 13. But don't put these in an array. First of all, you don't know how big the array should be. Because remember, we could run this program. Are you ready for 1 million and 1 numbers? See, there's 1 million. There's going to be 1 million and 1 numbers in the output array, in the data. There'll be 101. There'll be 1 million and 1 data points. So how big do you have to make your array? You have no idea how big to make the array. That's a good sign that you shouldn't be using an array to store these because you don't know how many of them they're going to be. And if you don't know how many they're going to be, it's kind of hard to have an array. Okay, so you don't need an array for those. Okay. So I wouldn't, you actually can't put these in an array because you don't know how big the array is going to be. And don't create an array of 10 million thinking that that'll be big enough because that's a bad strategy. That doesn't solve the problem because the data could be larger than that. And your program may not be able to run. If you create the array too big, your program won't run. You won't have enough memory to run the program. So there's a limit to how big of an array you can create. there are limits to the amount of memory you have. So don't create an array for the data. If you want, create an array for the results, for the tabulated data. Create an array for the results, but don't create an array to hold the data. Okay. Well, other questions? Any other questions? Okay. Okay. Again, this is real good stuff to go over, because what this is getting at is not just programming Java, but using the computer. Java programs run on a computer, and it's really kind of sad that the textbooks, I mean, even this other textbook I just showed you had a chapter on tooling. It was in an appendix. It was really kind of separated from the whole rest of the book, and the book never referred to that stuff. It would really be better if we could teach you how to use your computer. But one problem is there's too many different kinds of computers out there. So like you've seen here today, some people have a Mac, some people might have Linux, some people have Windows, and how you do things on a Mac is a little bit different than how you do things on Windows. So that becomes kind of a problem. It's real good to learn how to use your computer, but it's kind of a problem when different people have different computers set up different ways. So here, I'm trying to force the issue a little bit, try to get you a little bit to make use of files and make use of these test scripts. And it makes things a little bit messy. It makes things a little bit more tricky. But it's good. It's good. It's worth the effort. It's worth it puts an extra layer of complexity in here, but it's good, because that's what, we should be teaching you, the things you're going to really face in the real world, like working with, eventually in the next, you'll start learning more and more about the command line. Like here, you can just double click on these test scripts. You don't have to open the command prompt. You don't need the command line. You don't need that. You can just double click over here. Okay. Okay, and then when I double clicked on that, everything ran. It read that file and it sent it to this other file. Things happened when I double clicked on it. So, but that it adds complexity to it. It makes things a little bit. It adds more places where things can go wrong. So it adds more places where people need to ask questions. But that's okay, because asking questions and seeing things go wrong and then fixing them is a good way to learn. You almost always learn from mistakes. You don't learn when everything's going well. You're actually usually not learning as much. The more mistakes that are happening, probably the more you're learning. And that's actually one of the things in a job. People realize that that it's from the mistakes that you learn, that you start learning how to fix things, and you learn more. Every time there's a mistake, you have to fix it, and that's a chance to learn something. So if everything is going smoothly, it's because you're using knowledge you already have, and you're not learning anything new. Okay. All right. So now let's go to any last question about the homework assignment. Okay. Well, we've been working with classes. So we've been working with this rectangle class. And I think we've done as much as we can with the rectangle class. We've introduced a lot of ideas with it. Like remember, one of the real important ideas was that we want some of the fields to be private, because we want to make sure they don't get bad data in them. And this is one of the really most important ideas. This is one of the things. This is actually the reason they created object-oriented programming. This idea that some things in the object need to be protected, and then you could make sure that, for example, that the width and height are negative. The width and height are never negative by making them private. And then if somebody gives me a negative width in the constructor, I throw an error. If somebody gives me a negative height in the constructor, I throw an error. So, and then later on, if somebody wants to grow the rectangle, but they try to grow it to have a negative height or a negative width, we throw an error. That was really one of the main reasons for creating object-oriented programming, was to have a way of protecting data. In fact, most books would teach you that all this data should be private, not now the X and the Y don't have to be protected. So in this case, they don't need to be protected, because you can put any number into X and you can put any number into Y. The rectangle could be anywhere in the plane. So these don't need to be protected, but a lot of books would tell you they should be. Now, if you do protect them like that, then it becomes a little bit of a met. You have to do more work because now no one can read the X variable. No one can read the Y variable. So if you do make them protected, you have to go down here. See how we had get height and get width. Now we would need a public way for someone to actually ask, well, where is this rectangle? So I would need a public double get X that just returns the X coordinate. And I would need another one for public. It returns a double, and it's going to get the Y coordinate, and it just returns Y. And if I want, I can say return this dot Y. That's which Y I'm returning. Now, in this case, the only Y in this program is this one here. So there's no ambiguity about which Y I'm returning. So I don't have to say here, where is it? I lost it where it was. I don't have to say this Y, but I can't. Same here. I can say this X if I want, or I can just leave it as X because there's only that one X. Okay. Again, people argue about this. If you don't have to write to this, should you write it or not? Okay. In the Java language, a lot of people prefer not to write to this when you don't have to. So a lot of people prefer that. Okay. And other people say, no, you should write to this because it makes it clearer. Some languages require you to write to this. A famous one example of that is JavaScript. JavaScript requires that you write to this here. So if you want to return this X in JavaScript, you actually have to write this X. In Java, you can do it either way. So I can do one, so, okay. I can check, if I compile this, see, it worked. The compiler didn't mind either way. I had one of them as just X, and one of them is this Y, and either one is good. Okay, So in this case, in the case of the Java language, it's which one ever you prefer. For starting out, it's probably a good idea to put the thises in there, so you know that you're talking about the Y that's in this object, the X that's in this object, because every object's got its own X and Y value. When I create multiple objects, see, the whole point is that when I have multiple objects, see, one object's got its X, another object's got its X. So right now, this is this object, not that object. So this dot X is there. This dot Y is there. Okay. So this is part of this is part of the language. You don't have to write it here, but it's still they're part of the language. Okay. Yeah. In that where I didn't write this X here, but it's there. It's still there, part of the language. And Java, when it's running, will use this to get to that X. If you get to this line here, line 58, you'll see that this arrow is still going to be pointing down to an object to get to this X. It's just that you don't have to write it. So that's why some people prefer to write it, because that's exactly what Java is going to do when it's working. It's going to use this arrow to get to the object where Y is. So this arrow points to the object holding Y. Okay. Now, if I don't make if I don't make these things private, I don't need the get methods. Okay. But if I make these private, then I need the get methods. Otherwise, nobody can see what's inside the point. Seeing what's inside the rectangle. Now, I don't need to set X and Y because that's what the moves do. The move commands change X and Y. So if I want to change X and Y, I call move by or move to. Now, if these things are public, I could just change X and Y just by poking numbers into okay. So if these guys were public, I could take any rectangle and just change its X value and change its Y value. Okay. Now, right now, this won't compile because I made X and Y private. So if I make X and Y private, see, X has private access in rectangle. See, that line didn't work. If I make X and Y private, the only way to move a rectangle is to call my move methods that are in the rectangle class. If I make X and Y public, then I could change, like if I go back here and make this one public, and make this one public, then I can move a rectangle by either just updating the X and Y coordinates or by calling the move methods. So now this one will work now because I made X and Y public. Okay. And if I want to see that happen, build the rectangles. Okay, there's rectangles 4 and 5. This is just going to reach in to R5 and change what X is. It's going to reach into R5 and change what Y is. See, just reached in there and reached in there. Okay, didn't need to call a method. Now that's okay because there's no value of X that's illegal. There's no value of Y that's illegal. So it's okay if I let people put anything they want into X and Y. But it's not the case that any width is legal. Negative widths are illegal, negative heights are illegal. So I definitely need to have those private. Notice that there's nothing in the picture to show you which of these are public and private. Sometimes a visualizer will maybe use a different, something to denote the fact that some of these variables are public and some of them are private. The visualizer isn't showing you that. Okay? It turns out now the X and Y are public and the width and height are private. Sometimes they could use a different font. They could use a slightly different color. They could either they might even put the words public and private in front of them. So different things will visualize this different way. The visualizer here isn't visualizing the fact that which one of these are public and which one of these are private. We have to look at the code to find that out. You know, we have to look over here to see that X and Y are public and width and height are private. Okay. All right. So this idea is called encapsulation. This data is kind of, if I make everything private, then the data is sealed inside of here. Okay. So if I go back to making it all private, which is kind of the way most books teach you to do it anyway. But a lot of books exaggerate this idea that you should make everything private. In real programming, there are times when it's okay to make things public. The majority of times, the data should be private. It's certainly true that the vast majority of the time in a class, the data in an object should all be private. That's the majority of the time that's the case. Though there are some cases where it's a good idea to make some of the data public. But in general, if in doubt, make it private. Okay. Then we call this idea encapsulation because we think of the data as being like, oh, let's see. Oh, now if I made those private, I have to get rid of these 2 lines of code. I can't have these 2 here now. You don't see it in these pictures, but what we think of is that the objects are like a sealed box where this data is sealed inside, and from the outside, you can't actually see inside here or do anything inside here. The Java program sees this as a sealed container. And if it wants to do anything with the data, it has to call your methods. Now, the methods aren't shown in the picture, but essentially attached to this object are all these methods. So we think of these methods as being attached to this object. And then it's the methods that are public. So this is all private. It's sealed. So it's encapsulated like a little capsule. So you think of this box as a little capsule with the data inside. But the capsule has an interface, like a GUI, so like a console where you have buttons and an LCD. And these are like the buttons that let you access what's inside the capsule. So you can call get height and get width to find out what's in this thing here and this thing here. You can call get X and get Y to find out what's in here and what's in here. But you have to use these things here. You have to use this, what we call the interface. This thing's a sealed capsule. To see what's inside, you have to ask permission with these methods. You have to ask the methods to tell you what's going on in here. And if you want to change what's in here, you have to have the methods make the changes. Okay, so for example, the real important one is the grows, or the moves. Because the move methods will make sure that you don't, no, the grow. The grow methods will make sure you don't make the width and height become negative numbers. So you have to use this thing to actually change what's in there, but it's going to make sure you don't do something bad like make width -1. Okay, so we call this encapsulation. The data is sealed inside of the object, but the word encapsulation, you think of a capsule, most capsules don't have little interfaces on them. So I'm not sure, it'd be nice if they came up with a better word for this, because it's a sealed box with an interface to it. So the sealed box has got these public facing buttons and LCDs where you could ask questions and give commands to what's inside of the box. Okay, so it's an encapsulation with an interface. And we do call these methods the interface. These methods are called the interface to the object. Okay, and you use them to do things with what's inside of the object. Now, if you make anything in the object public, then you don't need the interface. Okay, if a field in the object is public, then there is no real interface to that field. Okay, it's like there's like a little open window to the capsule, and you can reach inside of it. Okay, but usually all the data in the object is private, so the data is all encapsulated inside the object, and you have to use the interface to make any changes inside the object. Okay, so that's one of the cornerstone ideas of object-oriented programming, the idea of encapsulation, private data, public methods that give you an interface to the data. They let you do convenient things with the data, like move the rectangle around. And notice that we have different ways of thinking about moving. We could move to and we can move by. So we give kind of convenient ways to think about, it isn't just set X to this and set Y to this. In this case, it provides a person a way to think about, like, what if I just want to grow the rectangle? I want the rectangle to be 1 unit wider. Okay, that would be grow by. So I don't have to really think about how big. I don't have to know how big the rectangle is. I can just say, oh, I want the rectangle to grow to be 1. I would want delta width to be 1 and delta H to be 0. And then it'll make it 1 unit wider. Whatever it was, it becomes 1 unit wider. On the other hand, suppose I want it to become a square, a 10 by 10 square. Then I would say grow to 10, 10. So the interface gives me nice ways to think about how to use the data. If I just had set width and set height, I could do everything I want with set width and set height. But then if I wanted to, for example, make the width grow by 1, I'd have to call get width to find out what the width is. Then I have to call set width to set it 1 larger. Okay. If I just had a set width, it would be kind of inconvenient. It wouldn't be as convenient as a grow by and a grow to. The grow to would be essentially set, but grow by would be more complicated. If I wanted to grow the width by 1 unit and I don't know what the width is, I'd have to ask what the width is, add 1 to that number, then set the width to that result. So I'd have to make 2 calls to grow by 1. Okay. So this is convenient. I provide what I think of as a convenient way for somebody to reach inside the box and make changes. So I provide an interface, a way I think would be convenient for them to manipulate the data that's inside of the object. Okay, so that's what we do in object-oriented programming. We figure out what data should be in our object, and then figure out a way to make it give people reasonable ways to manipulate it. Okay, like let's do a real similar example to this one. Another geometry, let's do a circle class. Okay, so what would be a circle class? So the main method is really not going to be part. The main method is really not part of the class. It's really for testing it. Remember, in the rectangle class, one way we did that was we had a separate public class for test rectangle, and then the rectangle class is down here. Or we could do like we'll do here. We'll just leave the main method inside the circle class, and then we can use it to test it. Or we could pull it out and put it in a separate test circle class. Okay, now what's in a circle? I'll make it private, double radius. A circle needs a radius, okay? And I could also have a center. So I'll just use X for the center coordinate and Y. So, okay, so there would be the data for a circle. You'd need to know where its center is and what its radius is, okay? And now I need constructors. So I need to let you build a circle object. Well, when you build a circle object, you need to tell me what the new radius is. You need to tell me what the, now here I'm going to do something different. I'm going to say, just tell me what the radius is. Okay. Well, if you tell me what the radius is, and you didn't tell me what the center is, I'll just set the center equal to 0. I'll just set the center point. I'll default the center point to 0, and I'll say that this radius equals the radius you gave me. Okay. Now, if I want, I could put the this is in front of here. So this X is 0 and this Y is 0. Okay. Now, this is, a lot of times if somebody just says, I want a circle of radius 5, then you can assume that they want it at the origin. Okay. So it makes sense to say, okay, you can give me just the radius and I'll give you a circle centered at the origin. Okay. On the other hand, I might want another constructor that lets somebody decide what the radius is, what the center is. Okay, so notice I have two constructors for this circle. One that says, just give me the radius, and I'll default the center to be at the origin. And one that says what the radius, the center, and So in this case, now notice I end up typing a lot of redundant things. This is actually really common about a complaint that people have about JavaScript. You keep writing really similar kind of code. So this X equals X, this Y equals Y, and this dot radius equals radius. Notice here I need the thises because I gave these variables the same name as I used up here, which is pretty common. Once you get used to it, it actually makes things a little bit easier to read. You realize right away that these parameters are going to be these things up here. If I give these things other names, then you might think, well, what are you going to do with them? But if I call them radius X and Y, you're pretty confident that they're going to go up here for radius X and Y. So, but then I have to write it this way. This X, which is this X up here, gets the X that's over here. Okay, this X is this X. This X is the field X. Okay. All right. But I have to type all these things over again. Now now you might also say, what about just X and Y? What if you do public circle double X comma double Y? Okay, now if you only give me the X and Y, I have to come up with an idea for what the radius would be. Now, some people might think, well, okay, this dot X equals X. You know, I notice I have to keep writing the same kind of thing over and over again. But the question now is, what about this dot radius? Okay, should I set it equal to 0? Probably not. Circles with radius 0 aren't very interesting. Yeah, should I set it? Another possibility is, okay, just give a circle of radius 1. The circle of radius 1 is used a lot in math. So if you just give me a center, I'll give you a circle of radius 1 at that center. That's not so bad. Okay, that's probably better than making it 0. Notice I have to make a choice here. Yeah, radius 5 would seem eccentric. You know, would seem weird. You know, why in the world would you make it 5? 0 is probably not a good choice. There really isn't such a thing as a circle of radius 0. That would just give you a point. 1 is maybe not a bad idea, because in a lot of math you use circles of radius 1. You could also just not do this. You could just not have this constructor. You could say, okay, you can give me the radius. I'll default to the origin. That makes sense. Or you could give me all 3 values. And you could decide, I don't like this either. So you could either completely remove that and just say, I'm not going to have a constructor that takes only X and Y. Or you could say, okay, I'll leave it like this with radius is 1. Okay. Now, like the rectangle, radius shouldn't be negative. So I really should also have a test in here. Okay. If radius is less than, and I can even, like, you know, the question, do I want, is 0 okay? I'll say no. Let's say radiuses always have to be positive. If the radius is less than or equal to 0, we'll throw new error. Okay, so we'll just let the program, we'll say that doesn't work. You know, you're not supposed to have circles of negative radiuses. Okay, so that needs to be there, and it also needs to be in this one. Okay, so if they give me a negative radius, we'll throw an error. Okay, now this one, I'm setting the radius, so I'm setting it equal to 1. Okay, all right. Now at this point, I should have a legitimate class. I should be able to create a circle object. Now, what about a circle with no parameters? Okay, I didn't define a circle with no parameters. And see, it doesn't exist. See, there is no circle. There is no default circle. I could make one if I wanted to. Like up here, I could say, well, okay, I think there should be a default circle. Now, this is a choice. This is really a design choice. Public circle, nothing. If you don't give me any information, what circle should I give you? Well, I'll put this dot X at the origin and this dot Y at the origin. And since I defaulted to radius 1 in this case, I'll just give you a circle of radius 1 centered at the origin. Okay, that's my default circle. Now notice I don't have to have a default circle. If I want there to be a default circle, it's the circle with it's the constructor with no parameters. Okay, now this one's okay. Yeah. And if now I have the default circle is just a circle with, you know, radius 1 and center 0. Okay. If you don't have to have a default constructor if you don't want. The constructor that takes no parameters is called a default constructor. So this is special. You don't have, if you don't think it makes sense to give all your fields a specific value by default, you don't have to have a default constructor. You know, so you don't have to have this one's sometimes called the full constructor because it defines all the fields. In this case, there's 3 fields. And notice that I have these other constructors that are in between. This one lets you define the radius. This one lets you define the center. If you define the center, I give you a default radius. If you define the radius, I give you a default center. So notice I have a lot of, I can choose to give you lots of different kinds of constructors. The only one I probably really have to have is this one. Okay. The other three are really optional. This one lets you choose what's in X, Y, and radius. The others are just for convenience. If you just want to specify the radius and have the circle center at the origin, you can just call that. And a lot of what we do in programming is choosing to design things just for convenience. This one needs to be there so that we could put X, Y, and R, put these, so we can put everything in the circle we need. These others are, well, if I think that's useful to programmers, I'll put it in my class. If I think this is useful to people using this class, I'll put it in there. Okay. Now the next thing is like, what other things would I think is useful? Okay. Now these are private, so nobody can see what's inside of a circle. So if you want them to be able to know what's inside the circle, now you have to start letting them see what's inside. So now you would need things like public double get radius. Okay. Now it's traditional to call it get something. You know, you could just call it radius, and it'll return the radius. Now there's no parameters. This thing's just going to return this dot radius. Okay. I don't need to put this here. Now that will work, but it's kind of traditional to call it get radius, which is actually, to me, and in fact, I think calling it radius is fine. That would be down here. I would just say something like double R equals C1 dot radius. Notice that, like, when you have strings, you don't call get length, you just call length. Okay, you just say string dot length. So I mean, a lot of textbooks teach you to call this thing get radius, but a lot of the times using the word get is a little bit overdone. You know, in this case, it's probably, I think it's more elegant to just say radius. Okay. Now, on the other hand, for the X, having a method called X is not so great, probably. Okay, that just kind of looks weird. A method called X. So for this one, I think it would be better to say get X. Okay, and then get Y. So I think here it would just be kind of maybe better to call it get X. Here I think it'd be better just to leave this one radius. It returns the radius. This one, because the name of the field just is X, calling the method X, you could, Java isn't going to complain about it, but it might just seem a little bit weird to have a method called X. Okay, so get X might work better here. Okay, so now what I'm doing now is I'm designing a class. I'm deciding what should be in here. What like what do people really need? Eventually, we'll do things like with the rectangle. We would want people to be able to move the circle around, maybe grow it and shrink it. Okay, but we're out of time, so we'll quit here. Okay, but the key thing is that this is a big part of what we do with object-oriented programming. Is once somebody decides what you are designing, like a circle, a rectangle, a triangle, then really it amounts to figuring out what data goes in it and what constructors you want to give people. Like how do you want to let them construct? Do you want a default constructor? If you almost always would have a full constructor. Do you want a default constructor? A lot of times you don't. A lot of times there are no obvious default values. And then you might ask, what about these partial constructors? How many of them should you have? Then after you choose your constructors, then you start thinking, well, do I let people have access to the fields? Do I want them to know what's inside of the object? Sometimes you do and sometimes you don't. So then you give them access to being what's inside the object. Then you ask, should they be allowed to change the object? Should they be allowed to move the circle? So then you just keep going through. How much data do you put into the object with the constructors? And then how much data can you access? And then how much data can you update in the class? Okay, so we'll do more examples with this on Thursday. That'll be our last day. Oh, and then on Thursday, there's one last thing, just to remind you that there'll be the last test, and there's some review problems here. So if people have questions about these review problems, we can go over those on Thursday. So remind me about that. If you have questions about these, Thursday's a good day to do those. So if I should forget, remind me. If anybody's got any questions about the review problems, you can also send me email or come to office hours. But if you have questions about the review problems, we could do those on Thursday also. Okay, so we could look at the review problems. Okay, all right, so we'll quit there. And if if you have questions about the homework assignment, it's due this evening, but like I said, beginning of class, if you could turn it in anytime this week or early next week, that'll be fine. And then if you have questions about the review problems, send me email or we'll ask on Thursday. Okay, so any last question? Anybody have a last second question? Okay, so stop there. Meet again on Thursday. Goodbye.